first type of chamber, the Labyrinth chamber. How does that work? The Labyrinth chamber relies on the fact that the density of the well fluids is higher than the density of your motor oil. If you produce from a well with a very low density fluids, and if the density of that fluid is lower than your synthetic oil in your motor, you cannot use a Labyrinth. So that's the first thing that you must have if you want to use a Labyrinth chamber. You must make sure that the density of the fluid that you produce from your well is higher than the density of your motor oil. I made a schematic of a Labyrinth chamber on this part of the slides. So of course, the bottom of your protector is connected to the motor, while the top of your protector is connected to your pump intake. Through breather tubes that we can see over there, the well fluid is going to be connected to the bottom of your Labyrinth. So it is through this breather tube over there. It's going to connect the well fluids that you have at the top of your protector. It's going to connect it to the bottom of your Labyrinth chamber. While this second breather tube over there is going to connect the motor to the top of your Labyrinth chamber. Now let's take a look at an oil expansion cycle to see how the Labyrinth operates. So first you will have an initial balance. This is what we can see over there. As the density of the well fluid is higher than the density of the synthetic oil with which your Labyrinth chamber is filled, what's going to happen is that initially your breather tube is going to get filled by well fluids and it's going to fill the bottom of your Labyrinth chamber, meaning that it's going to expel the synthetic oil which was contained in this area over there. It's going to expel it in the top of your protector. After this initial balance, at some point you will start your motor. And as you start your motor, the temperature in your motor is going to increase. Therefore, the synthetic oil contained in your motor will expand. And so this synthetic oil is going to come up this breather tube and go and fill the top of your Labyrinth chamber. So that's what we can see happening over there. As the synthetic oil expands, it moves up the breather tube, fills the top part of your Labyrinth chamber, and as this happens, this is pushing down the synthetic oil contained in your Labyrinth chamber, and so this synthetic oil is going to move up that breather tube and then be expelled by the top of your protector, where it's going to mix with the well fluids. On this part of the slide, what I wanted to show is to show the communication hole that we can see over there, which is part of your pump intake. So the pump intake which sits on the top of your protector. And it is through this communication hole that the fluid which is expelled from your protector is going to be expelled from your pump intake into your wellbore. So it is through this communication hole that we see over there. In case instead of having a pump intake between your protector and your pump, in case you have a gas separator, I'm sure you are familiar with this. Anyway, this is something that I will present in another course. In case you have a gas separator, you can see that you have the same communication hole at the bottom of your gas separator, which in this case replace your pump intake. Now let's take a look at your Labyrinth behavior in an oil contraction cycle. When your motor stops, the temperature inside of your motor is going to decrease. Therefore, the motor oil will contract. The consequence of that is to avoid the collapse of your motor, it will suck the oil from the protector. So that's what's going to happen. Oil from the protector is going to move from the top of the Labyrinth inside of that breather tube and then go down to fill back your motor. By doing so, you will keep the pressure inside of your motor constant and you won't have a decline of pressure, and so you won't have a collapse of your motor. As this oil is going out of your protector to go to your motor, then what's going to happen is that the protector is going to suck well fluids to replace this oil which is moving back to the motor. So this well fluid is going to be sucked through this communication hole on your pump intake. And so over there, let's take a look at the fluid movements. So the oil is moving back to the motor, and we can see that more well fluids has entered and filled the bottom of your labyrinth chamber. To replace the missing volume of oil, so this volume that we had over there, this volume which has been pushed back into your motor. So if the labyrinth chamber works properly, then this same volume of well fluid is going to be expelled back at the next expansion cycle of your motor oil. And so in theory, every time you have an expansion cycle, you expel the well fluids, and every time you have a contraction cycle, some well fluid gets back in the protector, which is going in turn to be expelled back at the next cycle. And you should have a rather constant quantity of well fluids contained in your labyrinth chamber across the expansion and contraction cycles. So as we can see, the labyrinth chamber allows to segregate the well fluids from the motor oil. And we can also see that as your labyrinth chamber is connected to your pump intake and basically to the bottom of your well fluids through this communication hole, the pressure inside of your labyrinth chamber is going to be the same than the pressure outside of your protector. So at the bottom of your well, you will have the same pressure over there than your bottom hole pressure.